Right, this here is a free fall question, and there's two parts of this journey as well. So this here going up to the top over here is actually our part one of the journey, and dropping is actually part two. And it says here before impact, the speed is 12.5 meters per second, and going up. So this object is thrown upwards with 6 meters per second. So we're going to calculate all the SUVAT sort of parameters that go with this. So the first thing we're going to do is we're going to start off with what is the speed up here? Well, if you take a snapshot of what happens right at the top of this, the velocity is actually zero right at the top, and that's because there's been a switch. It goes from this direction, going upwards to downwards. So right at the top, we've got a velocity of 0 meters per second, and u coming down for part two of the journey will be actually 0 meters per second as well. So we've got u on this side, and this will be v for our part two of the journey. And we can also determine what acceleration is going to be here as well. So acceleration for all of this is actually 9.81 meters per second squared, and this here is acting in the downwards direction. So what we can do is, the first thing we can do is we can calculate the distance over here, because we've got a, v, and u, and we're after s and t. So we're going to calculate s for this part of the journey. So s is actually going to be equal to v squared minus u squared divided by 2a. So let's have a go at that. So v squared is 0 squared minus 6 squared, v squared minus u squared divided by 2 times minus 9.1. And it's a minus because it's acting downwards. Anything going upwards, so we can write this down as well. Anything upwards is in the positive. Anything downwards is going to be in negative. So this is the rule that we're going to stick by when we're solving this one. So this here, the distance it goes up by is actually 1.83 meters. T is actually quite simple now. So T is just equal to v minus u over a. So if we put our numbers in this time, so v is 0 minus u, which is 6, and then we divide it by minus 9.1, we get an answer of 0.61 seconds. So that's what we've got for that one. And we do exactly the same for this side as well. So s is equal to v squared minus u squared all over 2 times a. For this one, it's going to be v squared is actually 12.5 minus 12.5 actually, because it's heading downwards. So minus 12.5 minus 0 squared, so I forgot the square bit on that one, divided by 2 times by a negative 9.1. So s in this case is actually 7.96 meters, and t is v squared minus v minus u all over a is going to give us that one. So v is minus 12.5 minus 0, and it's a minus 9.1 coming down. So therefore t is 1.27 seconds. So I've worked out all those parameters for free fall in that one.